But it's not wrong. Okay, so 7-8 is just when we start getting into actual i's. We haven't had any i's yet, so now we're going to have complex numbers. So just a reminder, the square root of -1 is I. So how we remember, if we have the square root of -n, that's the same thing as the square root of -1 times n. So then we would pull out an I, and that would be I square roots of n, right? Thanks. So then let's simplify these. This becomes 4i. This becomes I square roots of 3. There's so many people that call that 3i. Don't do that. 7i. I square roots of 7. Okay, good. So complex numbers have the form a plus bi, where a is the real part and bi is the imaginary part. So right here, this is a complex number. A plus bi. So a2 is the real portion, -6i is the imaginary portion. We always write our answers as the form of a plus bi. So if this was written as -6 plus 2i, you then reorder it real quick for your final answer. All right, so let's look at rewriting this in the form of a plus bi. That would be 2 minus 5i, right? Pretty easy. Okay, awesome. So now let's look at this one. First of all, you'd say, okay, I'm going to break down my radical. So I have -1 times 50. That's 5 times 10, 5 times 2. So we'll pull out a 5. We'll pull out an I. So we have 3 plus 5i square roots of 2. A plus bi. Questions on that? Okay, great. Doing great. Okay, looking at this one, don't be that person that divides 4 and 2 out. This was also divided by 2, so you can't divide across the subtraction sign. So this is -1 times 12. This breaks down into 4 times 3, 2 times 2, so we'll pull out a 2i. So we have 4 minus 2i square roots of 3 all over 2. And now you'd say that's my answer unless it can simplify. On top, we can technically factor out a 2. Divide by 2, divide by 2. Left is 2 minus I root 3. And that was all over 2. So now our 2's divide out. Does that make sense? Or you can think of it as all 3 things divide by 2. Divide this by 2, it's a 1. Divide this by 2, it's a 2. Divide this by 2, it's a 1. Right? Same way of thinking, Fearless. Different way of thinking, same idea. Okay. All right, awesome. So now, guys, when adding and subtracting complex numbers, you can only add the real part to the real part, the imaginary to the imaginary part, which is pretty straightforward. So we just have to be careful. This says simplify. Simplify can mean many things. In this problem, it says add. So addition, we don't have to really be careful with. 4 plus -2 is 2. -3i plus 5i is 2i. 2 plus 2i, a plus bi. So adding is really easy. Combine like terms, essentially. So looking at this one, I would rewrite this. This is actually 4 plus 5i, plus sign 6 minus 4i. So then combine real parts with real parts, 10, and then we have plus 1i. So addition is not the one that gets missed on the test. It's subtraction. So make sure if it's subtraction, distribute your negative. That's now -5 plus 4i. All right, combine like terms. -3 minus 5 is -8. -7i plus 4i is -3i. A plus bi. So just be careful with subtraction. Just like the entire year, we've had to be careful with subtraction. All right, so with this one, let's practice this one. This breaks down into 4 times 3, 2 times 2. So 2i root 3. We have 3 plus 2i root 3. Minus sign. We have -2 minus. Good, so 3 and 3, so that's why you're saying 3i root 3. True? Combine, well, first of all, subtraction, I'm going to distribute my negative, so that's plus 2 plus 3i root 3's. And now combine the real parts with the real parts, imaginary with the imaginary. So 3 plus 2 is 5. 2i root 3's plus 3i root 3's is 5i root 3's. How are you guys feeling about this? Okay, great. All right, so this is the last thing we have to go over. Just to recall, if the square root of -1 equals I, then when we square both sides, it's also true to say I squared is equal to -1. They are equal, so if we distribute this, it says multiply, that would be 12I, right? And we have -24, careful, because an I times an I is an I squared. So now we have this, 12I minus 24 times by -1. That is not an addition sign, that is a times sign. -24 times -1 is plus 24. So you'd write your final answer as A plus BI, so we'd have a positive 24 plus 12I. Don't mess up on your I squareds. So usually where people mess up is they'll not, when they have an I times an I, they won't write I squared, they'll just write I. I'm waiting because people want me to wait. You guys ready? Yeah. Without a negative? Yeah. The square root of 1 is just 1. All right. All right, so let's look at this one. This one has two terms. We're going to distribute, double distribute. -2 times 3 is -6. -2 times -I is plus 2I. 4I times 3 is plus 12I. Right here is usually where people mess up and they don't realize it because it doesn't give anything alarming if you mess up. A lot of times they'll write -4I because they're just messing up. I times I is not I, it's I squared. So if you just write -4I, you're not going to catch it. You're just going to combine your i's and you're going to have the wrong answer. So be careful. Down right here, that is -4 times by -1, which is plus 4. Do you guys still have rewritten it? So then 4 plus -6 is -2. And then we have plus 14i. We are almost done. Okay, looking at this one, we won't go through it, but I just want to rewrite this at least 2 plus 6i times 4 minus 5i, and then you would double distribute, right? What would this final term be? -30i squared, which would become plus 30. Okay, good. All right, so just look at, there's a reason I'm doing this one. There's a point here. These are conjugates, correct? Now remember, with our radicals that were conjugates, our radicals canceled out. Well, the same thing's going to happen with our i's. If you have conjugate pairs with i's, we're going to just get nothing with no i's. So you have 4 times 4 is 16, and then you have a minus 12i, and you have a plus 12i. Your middle term is going to cancel out because that's what conjugates do. Right here we have minus 9i squared. So middle term cancels out. I have now 16 minus 9i squared, which is really 16 plus 9, which is 25. Do you guys see how when we have conjugate pairs, the i's cancel out? No i's. Well, that's going to be useful in the future. So let's look at this problem. So it says simplify. So this is technically dividing complex numbers. Now the problem is exactly like a radical. You can't have an I in the denominator of a fraction. So we get rid of the I by making it just a number instead of an I. So how do we undo an I to make it a number? Multiply by I. Very good. Times by I, because then won't it be I squared, which is -1. If you do that to the bottom, you've got to do it to the top and use parentheses. So on top, I distribute, and I get 3i plus 4i squared. On bottom, I have 2i squared. Now you'd say, okay, I don't divide across addition signs. I'm not going to divide out I squared because that is not what we're doing here. However, we know I squared is -1. So isn't this 3i minus 4? 4 times -1 is -4. Divided by 2 times -1 is -2. Then they are going to take and rewrite this appropriately. First of all, the top should be written as a plus bi, so that's -4 plus 3i. And then that's all over -2. It's not really the best idea to leave a negative in the bottom just because it's not going to match up with the book. So I would take my negative and I would divide everything by -1. So this becomes positive, negative, positive. Do you guys see how I've just taken the negative up to the top? So then you'd say 4 minus 3i all over 2. Can you divide out 4 and 2? No, don't be that person that divides across a subtraction sign. That's bad. Okay. How do you guys feel about that? Okay, awesome. You guys are doing great. Okay, right here, what am I going to do? Times by I. Times by I. I'm going to do it so quick. So then I get negative 4I plus I squared all over 3I squared. So on top, let's reorder in A plus BI form. What's going to be? Negative 1 minus 4I all over. So then don't all of them divide by negative 1. 1 plus 4I over 3. Okay, so this is my last example here. We have an I in the denominator and there's two terms. So it's kind of like rationalizing. We multiply by the conjugate, right? Because if I multiply by I, won't I just distribute I and have an I again? Yes. Okay, so we multiply by 1 plus 3I. 1 plus 3I. Two terms on top, I've got to use parentheses. So now I'm going to do my top work right over here. 4 times 1 is 4, plus 12I, plus 3I, plus 15I, and then plus 9I squared. So that's actually minus 9. Negative 9 plus 4 is negative 5, and then we have plus 15I. That's our top. Let's do our bottom. 1 times 1 is 1. Plus 3I minus 3I cancels out because that's what conjugates do. Minus 9I squared. So that's actually plus 9. 1 plus 9 is 10. And then don't all three things divide by 5. As long as we do it to all three pieces, correct? Or do it by factoring the top. So this divides by 5 and becomes a 2. This divides by 5 and becomes a 1. This divides by 5 and becomes a 3. So that's negative 1 plus 3I. all over 2. And that's your final answer. How do you guys feel about this lesson? Good, not good? Good. You're supposed to say so that my video, everyone's like, whoa, she's a great teacher. Instead of crickets. Thanks. I'm not going to do it, but what would I multiply by? 5 minus 3i. Okay, good. All right, that's the end of the lesson.